Okay, let's take the same problem and add a free integrator to it and see what we can do with it. I'm going to get a fresh page here. There's 100 s plus 30. And so let's say that we've got g is equal to 100 s times s plus 30. Okay, and so in this case, we calculate our DC gain, and remember, in this our DC gain in this case, we're going to ignore any free s's, and so our DC gain actually is going to come out to be the same as it was before. And so we can look back here, and it was 3.3 with a DC, or in dB, it was going to be 10.45. And so this is going to be 3.3, or in dB, 10.45 dB. DC gain. Okay, and so we're going to start off looking very similar to what we did before. 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, and let's go at 0, 20, 40, minus 20, minus 40, and we're going to plot this first point right in here at 10.45 at omega equal 1. All right, so we started off exactly the same. Now, the difference in this is our initial slope. Now, if we look at this, we've got this free integrator in here. And if we go back to our rules, we see that if we have a free integrator in here, oh, sorry, this one, then we're going to start with an initial slope of minus 20 dB per decade. Okay, so come down here, we're going to start with an initial slope of minus 20 dB per decade. So we're going to come in and we're going to start sloping in like this. Our initial slope is going to be like this, and we're going to run out to 30, which should be somewhere around in here. Our next pole and 0, pole or 0. And so we've got a pole here at 30. And so then we're going to add an additional 20 dB per decade. Okay? And so in this case, this is going to be minus 20 dB per decade. And then I'm going to come over 1 decade, and I'm going to go down 40 to end up with a point here, and my slope of my line at this place comes like this, and this will be minus 40 dB per decade. Okay, and so that's going to be our magnitude plot for our asymptotic Bode. Let's see what the phase is on this. Well, the phase is just the slope. The phase is going to be the slope times 90 degrees divided by 20 degrees per decade. Okay, so our initial slope in here was minus 20 degrees per decade times 90 degrees times divided by 20 degrees per decade, and so it ends up being minus 90 is our initial slope in here. So we start off at 0 here, and this is minus 90 minus 180. We're going to have an initial slope. Our initial slope on our phase is going to be minus 90 in this case. So that's going to run out here to 30. Okay. Now, at this point, we recalculate, and now in this case it's minus 40 times 90 degrees divided by 20, 2, minus 180 is our next. And so here at 20 we're going to shift to minus 180, and that's going to run out here like this. So our asymptotic phase plot would look like this. Again, we're going to step back 1 decade and forward 1 decade, and our plot would look something more like this, more properly. Okay, so that would be our plot, our phase plot for g equals 100 over s plus, or s times s plus 30. And so that would be the asymptotic Bode for that. Okay?